our project was the nuclear power probe, and our group name was Not Chernobyl. For the design process, for ASK, first we had to visit Burlington Labs and talk to our project guru, Mrs. Lisa Marshall. We emailed her to clarify instructions and ask for advice. For Imagine, we initially were going to use photodiodes, and we later used an Arduino for more accurate results. For Plan, Thomas, our head of design, drew the original plan for the probe, and we later drew another plan using that Arduino design. For Create, first we acquired all the necessary materials for the project, and we immediately started working. We cut an acrylic lens for the base of the probe and cemented the PVC pipes together. The Arduino and the sensor were placed inside the probe, and the USB cable was also run through the PVC. And then the sensor was attached to the lens with a piece of sticky tack. For testing, we couldn't do actual testing, but we held flashlights up to the sensors, kind of simulate the Cherenkov radiation. And for improving the project, we had some difficulties uploading the code to the Arduino originally, but we later fixed this, and the second test was much better. We also feared the Arduino would not work on test day, so we included a set of 6 photodiodes in series as a backup plan.
So this is kind of what our two designs looked like. And initially we used photodiodes, as John was talking about, and that's the design on the left. And then we later switched to an Arduino, which is the design on the right. And we actually ended up using both. The photodiodes were kind of our fail-safe for our Arduino if that ended up not working. And we cemented the acrylic lens on and electrical taped it onto the pipe to ensure some waterproofing. And there was just a USB cable that ran from the Arduino to my laptop and gave us all the information. And this is what it looked like on test day. We had to navigate all the hallways with a 14-foot PVC pipe, which is very hard. And this picture doesn't do it justice. It was incredibly long and hard to maneuver around. And this is what our sensor looked like, and it's behind the acrylic lens over here, and it's stuck on with sticky tack to kind of keep it in place so we can maintain accurate measurements. So now what you've been waiting for. How did we do that FED? Well, let's just say it was a heartbreaker. As you can see, it was supposed to be 750 kilowatts. That was our final one. Sorry, I'm emotional up here. We actually had a great power probe. We got to 739.4 kilowatts, which is incredibly close. If I'm not mistaken, I'm pretty sure we actually had the lowest error percent. It was 1.4, which is incredible. I guess we just didn't do everything right. We're not really sure, but I mean, you take what you get, you win some, you lose some. But as you can see, this is our test result in our graph. You can see the linear regression we designed over here based off of this equation from our points that we got. And again, we didn't place that FED, but we gave it our all. We had a great probe, and it was definitely a great experience. We're really proud of what we've done. What we should have done differently, maybe would have let us win. Well, it's good to have the team present at the table at all times, at least somebody, because you never know who you might miss, who you might not see. Just going to leave that one at that. And then throughout the process, take pictures constantly. We had a few pictures of our finished product, a few drawings and sketches of what Thomas did, but we didn't have any actual pictures of us building it or us cutting the lens or gluing it on. I think that would have been really cool to have so we could show the whole process. And then another thing we could have done, our sensors inside the probe that you saw earlier, we should have 3D printed a little housing mechanism that would have held the sensors in place instead of a sticky tack, because our sensors obviously not enough to skew our data, but it was scaring us because they were kind of coming out of place and we had to keep opening it up and fixing them. You know, if we'd have just 3D printed a little housing mechanism for them in the first place, then we wouldn't have had to worry about that. We could have focused on winning. But, oh well, we're proud of what we did. Thank you.
Last but not least, obviously we want to give some advice to next year's freshmen. First and foremost, be present at your table during the entirety of the competition. I actually want to elaborate on that. What you guys should do is find out from your TA and from whoever your professor is for your E101 lab and ask them what happens at FEDD, because we weren't 100% sure exactly how FEDD worked, and we're trying to figure it out as we went. So I think having a little bit of background before we went in and kind of knowing what to expect would have helped us too. Some more advice: meet early and often. We did a really good job of that actually throughout the semester. We met every week on Sunday nights for about an hour to an hour and a half, depending on what needed to get done, and that really kept us on schedule. Share the workload as well. I know that there's roles within the team, like myself, I was materials, John was our team captain, Thomas was our head of design, and Steven was our head of research. But we all kind of helped each other out and stepped up whenever the workload started to be a little too much on somebody, per se, so that someone didn't get overwhelmed and we were able to put what we thought was the best product out there for our project. Also, keep in constant contact with your project guru. I think this is something we could have done a little bit better because we were kind of scrambling at the last minute when she sent out some guidelines that were in there at the beginning. We just didn't overlook, or we overlooked them, and we didn't get clarification on a couple of things until it was very late in the process, and I think that would have helped alleviate a lot of stress. And then last, and probably most important, I think we would all agree on, is constant communication with your teammates. We had a group chat. I suggested group chat. We talked in the group chat a lot about what was going on. We kept each other informed of, hey, I did this, or hey, I did that throughout the process, and I think that helped us put out a really high quality product, and we had a really good project, and I think we can all say we enjoyed it very much. You know, the result at FEDD may have not been what we wanted, but we enjoyed the process, and thank you. And here is our works cited.